little video here is just review quickly correlation and also correlational methods and experimental design as a way to help you prepare to write your first hypothetical experimental design. So you've been looking at different research methods, and one of those you looked at this week was correlation. And what we really need to understand here is that correlation is a prediction method. We're really trying to see if the variable on the x-axis can be used to predict a variable on the right axis. So I'm going to switch here. So we could say, do murder rates predict number of ice cream sold? Because on the x-axis here is murder rate, and I'm trying to say, does this predict? It's a very interesting correlation, right? As murder rates go up, number of ice creams goes so, right? And we can only say, do ice cream sales, or actually it should be, do murder rates predict ice cream sales? If I wanted to say, do ice cream sales predict murder rates, then I'd have to put the x-axis be ice cream sold and the y-axis be the murder rates. But notice that this does not say, do ice cream sales cause murder rates to increase, or do murder rates cause ice cream sales, right? This is what we call an illusory correlation, because there's a third-party variable here, and that third-party variable is, anybody guess? It's heat, or being outside, right? If you're more likely to be inside not eating ice cream because it's cold, you're less likely to have interactions with others, which would lead to people being murdered. So when we have correlations, we're looking for prediction. Second thing about it is this very fancy ex post facto design. Normally what this means is that you have data, you have real world data, right? Number of ice cream being sold and number of people being killed. This is all already in the past. So you have collected data that has already happened. That's the ex post facto. And you're just looking to see, do these relationships exist? Can we predict the y-axis based on the x-axis? There is no manipulation of any variable. There's no researcher saying, if I give this to this group and then I give that to that group, does it cause some change? We're not looking at that. We're only looking to make these predictions. Now, we often talk about this perfect correlation, right? Perfectly meaning it's going up. This is a positive one. The positive has nothing to do with negative numbers in math. It simply means that as x goes up, y goes up, x goes up, y goes up. We have almost no perfect correlations in psychology. One of the best we have is on the x-axis is intelligence, and on the y-axis is academic achievement. So as you have a higher IQ, your academic achievement does go up, but it doesn't go up perfectly. It's only a 0.7 correlation, and that's about as best as we get. Now, a positive one correlation is just as strong as a negative one correlation, because the negative in this instance just means as x gets bigger, y gets smaller. All right, so that's the negative part, but both of these are in a perfect line, and both of them you will not see in psychology because we don't have any perfect correlations. All right, if we kind of want to check this just down here, I'm not going to do the top right now, I'm just looking at the bottom. How would you interpret a correlational coefficient of negative 0.87? Well, as x goes up, y goes down, that's the negative, and this is pretty strong, right? I just told you that 0.7 was as good as it gets. So this is going to be something that we would rarely see in psychology, right? It would be maybe in another field, but we don't tend to see them so strong. All right, so let's review. Correlation is almost always, we're looking at data that has been in the real world, and we're just trying to look for relationships to make predictions. We are not manipulating anything. There's no different groups going on. So in our project, we're going to, in your hypothetical investigation, we're going to look at something. You're going to make something up. We're just trying to see, right, how would we, if we wanted to design an experiment to look at the question, do we have some sort of issues going on here with smartphone use, right? Because here it says we've seen these relationships, right? They seem going up. We see as smartphone use and social media are going up, we have an increase in depression, anxiety, self-harm, and suicide. And should I say, this is a correlation, right? Should I start to tell your parents to take your phones away from you? Well, if you know anything about me, you know my kids don't have these phones because I don't think they do very good things for you. But what I want to see is, can you design an experiment to investigate this correlation? All right, so we need this one. This is what you've been learning about this week on experimental design. I'm going to go through just these key terms one more time, just if you need the review. We want to establish a cause and effect relationship. That means we want to know, in terms of, we want to know, let's say I want to know, does smartphone use, right? Does more smartphone use cause more depression? Right? That's what I'm trying to answer. You can do this how you want. I looked at a very interesting study the other day. It said, does smartphone use mean you're less likely to be able to read someone's facial expressions, right? We could take this, you can design your study in many, many ways. I want you to be thoughtful and creative, and I don't want to tell you exactly how to do it. But in an experimental design, in a true experiment, you're going to have an experimental group. This is the group that has something different done to them. You're going to have a control group. This is the group that doesn't have anything done. When we talk about those things, these are how we do our independent and dependent variables. Your independent variable is how you are grouping your people. What is the thing that you're doing to your groups to see, does that cause a change in the dependent variable? The dependent variable then is what you're measuring. So it could be depression. It could be reading someone's facial expressions. The independent variable is what are you doing different in these two groups? All right, now we got these two terms. They seem so close together: random selection and random assignment. I can actually change this color here very easily now. So random selection has to do with who are our findings going to apply to. And so this starts by defining what is our population. All right, we want to know, who do I care about? So if this whole circle is my whole population, in an experiment, I don't try to test everyone making up this population. I need to take a sample of them. I need to somehow get some of these people, and for this to be a good sample, everybody in here has to have an equal opportunity to be selected. And oftentimes what we do is we say, let's just randomly select. It doesn't always work this way, but this is the best way to take a sample. Now, who our population is who are we thinking it applies to? If we were looking at this question, well, we're looking at teen girls, and not just any teen girls, Canadian, American, and British teen girls. They would make up our whole population, and then we would be seeking to answer, well, how do I get a sample of them? Right? And this isn't always perfect, but if we can take a random selection of all of the British, Canadian, and American teenage girls, then my findings will generalize back to that population only. My findings will not apply to teenage boys because they're not my population. So we want to randomly select from a population, and that's who our findings will generalize back to. We also, once we have this group of people from the population, well, then we need to think, how are they going to go? I don't think it matters what shape we use, right? How are they going to go to this experimental group and control group? So I'm going to need two groups, right? So I took here's my sample, my random selected sample, and then I'm going to have to break them into my experimental group and my control group. We can even put these guys here. Maybe it'll look better, right? So my sample is going to go to these two groups, and this is going to allow me to control for everything that I can't control for, so I can establish a cause and effect relationship. And there's lots of more complicated ways of doing this, but for now, if you say, everybody here, I'm going to flip a coin, and heads are going to this group and tails are going to this group, that's random. Anything I didn't know to control for gets controlled for. All right, now, single blind versus double blind. In a single blind, the participant doesn't know what's happening. So the participant doesn't know if they're in the experimental group or the control group. sorry, this is the participant, they're blind, but the doctor does, or the researcher, whoever's there, right? So I would know whether you were getting something or not. And this can have problems because let's say that the researcher was the therapist and the question was, is my therapy helping? Right? The experimental group gets the new therapy form, the control group gets the original therapy form, and I am the researcher and I want to know, is it better? Well, because I know who's getting the new therapy, maybe I'm just nicer to those people and maybe that impacts my findings. All right, double blind is the researcher, the person who puts them in these two groups, is different than the person actually carrying out that therapy. They wouldn't know. All right, and this is very good because it helps from the influencer or from the researcher influencing the results. And usually, so that, come back to either single blind or double blind, so that the participant doesn't know what's happening, we often use what's called a placebo, because then both people are getting something and they don't know whether they're getting the real thing or not. And don't think that this is just so like not a big deal. When they study depression medications, there's often barely a difference between the placebo group or the experimental group and the control group, because the placebo effect is so very powerful. All right, so you can see that you're gonna conduct you're gonna write a hypothetical experiment. You are not going to conduct these studies. We are not allowed to do it. So you don't have to worry about money or ways that you can't do the study. You just want to write out a perfectly designed study. You're going to state your population. You're going to tell me how you collect your sample. You're going to say what research question are you trying to answer and what's your hypothesis. You're going to state the independent variable and the dependent variable. When it says state the operational definitions of these variables, you're just going to say this is so important in psychology, because if I say I'm measuring anxiety or I'm measuring depression, how? Right? The operational definition is that you're stating exactly how these things will be measured so that two people could do the same thing. We could repeat the study, because replication in experiments is very important. You're going to this is your methods section. How are you going to set it up? How are you going to control for confounding variables? How are you doing your groups? How are you doing your assignment to the groups? Is it single blind, double blind? What applicable biases do you think exist, and how might you solve for those biases? And then state your conclusions you could draw. What do you hope to be found? Who do you hope your research generalizes back to? And if you're able to write this hypothetical experiment, I'll be able to see how well you understand experimental methods.